interactive network of knowledge.
Integrals of some particular functions. First type, integral dx by x square minus a square is equal to 1 by 2a log of x minus a by x plus a with modulus plus c. So here our left hand side LHS integral 1 by x plus a into x minus a dx, as x square minus a square can be written as x plus a into x minus a. Then multiplying numerator and denominator by 2a. Since 2a is constant, the denominator part 1 by 2a can be written like outside the integral, and 2a by x plus a into x minus a dx. Then the 2a can be split into a plus a. Adding and subtracting x on numerator, we'll get 1 by 2a integral x plus a minus x plus a by x plus a into x minus a dx. So grouping the numerator, we'll get 1 by 2a integral x plus a minus x minus a, minus have taken common, denominator will be x plus a into x minus a dx. Then 1 by 2a x plus a by x plus a into x minus a, separating them, x minus a by x plus a into x minus a dx, so that in first term x plus a by x plus a gets cancelled, and second x minus a gets cancelled in both numerator and denominator. So we'll get 1 by 2a integral 1 by x minus a minus 1 by x plus a dx. Since here coefficient of x is 1 in the numerator in both the terms, so we no need to substitute again for x minus a as t. So directly we'll find the integration of integral 1 by x minus a dx and integral 1 by x plus a dx. So 1 by 2a integral 1 by x dx is log x plus c. So here integral 1 by x minus a dx is log of x minus a minus log of x plus a with modulus plus c. So we know that log a minus log b is log of a by b. So we'll get 1 by 2a log of x minus a by x plus a plus c. Second type is integral dx by x square minus a square is equal to 1 by 2a log of x by a x plus a by x minus a with modulus plus c. So LHS is integral 1 by same like previous type, a square minus x square can be written as a plus x into a minus x dx. Then multiplying and numerator and denominator by 2a, we'll get 1 by 2a integral 2a a plus x into a minus x dx. Then separating it, a plus a in the numerator, adding and subtracting x on the numerator, we'll get 1 by 2a integral a plus a minus x by a plus x into a minus x dx. So grouping again, we'll get the same a plus a minus x, then separating them with the common denominator, then we'll have 1 by 2a integral 1 by a plus x minus 1 by a minus x dx. So which is 1 by 2a integral of 1 by a plus x dx minus 1 by a minus x dx. So while integrate, we'll get log x plus a with modulus minus log modulus x minus a plus c. So again log a minus log b is log of a by b with modulus. So 1 by 2a log of x plus a by x minus a with modulus plus c. Third function, integral dx by x square plus a square is equal to 1 by a tan inverse of x by a plus c. So here, since right hand side, the answer, I mean integral dx by x square plus a square, we'll get tan inverse of x by a. So let us assume here the x is equal to a tan theta. Then tan theta will become x by a and theta will become tan inverse of x by a. Then dx, when differentiating x, dx will be equal to a tan theta is secant square theta d theta. Then our integral part will become integration of 1 by, instead of x square, a square tan square theta plus a square dx. But this dx, instead of dx, we can write a secant square theta d theta. Why? Because denominator we have a square tan square theta, so numerator will become, I mean the dx we have to change, so a square, sorry, a secant square theta d theta. Now when we integrate this, 1 by a integral d theta, because the secant square in the numerator and denominator gets cancelled, and then a is constant. If you take out, then 1 by a square will become a 1 by a square into a, so we'll have 1 by a integral d theta. So when we integrate this, we'll get 1 by a into theta plus c, where theta is tan inverse of x by a plus c. Fourth type, integral dx by root of x square minus a square is equal to log modulus x plus under the root x square minus a square plus c. So since here log is involved in the left hand side, just assuming x is equal to a secant theta, which in turn dx will be equal to a secant theta tan theta d theta. And from, since x is equal to a secant theta will be equal to x by a. Then tan theta will be equal to root of secant square theta minus 1. We know that tan square theta is equal to secant square theta minus 1. So tan theta will be equal to root of secant square theta minus 1. Then tan theta is equal to, instead of secant square theta, x square by a square we can substitute. Then it will be equal to root of x square minus a square by a. Let this keep aside. So our integral part will become integral of, instead of dx, a secant theta tan theta by root of a square secant square theta minus a square. Instead of x is x, a secant theta, so x square will have a square secant square theta minus a square. Then numerator as it is, denominator a square we can take common from both the terms under the root, so that outside the root we will take a, then a secant a root of secant square theta minus 1 d theta. So which is numerator and denominator, a gets cancelled, we will get secant theta tan theta by tan theta d theta. Then tan gets cancelled, we will get integral secant theta d theta. So log of integration of secant theta is log of modulus secant theta plus tan theta plus c. So log of modulus secant theta is x by a plus tan theta is root of x square minus a square by a plus c. So when we take LCM, when we simplify the thing under the modulus, we'll get x plus root of a x square minus a square by a. Since here we have log of b by a or a by b, we can write log a minus log b. So log of x plus root of x square minus a square with modulus minus log a plus c. So this minus log a is again a constant. So constant plus constant is again a constant. So finally we'll get log of x plus root of x square minus a square plus c. Then fifth type, integral dx by root of a square minus x square is equal to sine inverse of x by a plus c. LHS is integral dx by root of a square minus x square. Since sine inverse of x by a is given, in right hand side we'll take x is equal to a sine theta. Then dx will become a cos theta d theta. Then from this x is equal to a sine theta, we'll have sine theta is equal to x by a, theta is equal to sine inverse of x by a. Integral part, integral a cos theta by root of a square minus, instead of x square, a square sine square theta d theta. Then a can be taken out common, we'll get under the root 1 minus sine square theta in the denominator. Then 1 minus sine square theta is cos square theta. So when we take outside the root, it will become cos theta. So integral d theta, which is equal to theta plus c. So sine inverse of x by a plus c. Sixth type, integral d by root of x square plus a square, which is equal to log of modulus x plus root of x square plus a square plus c. So our LHS is dx by root of x square plus a square. So x is equal to a tan theta, then dx is equal to a secant square theta d theta. Then tan theta is equal to x by a, then secant theta is equal to under the root 1 plus tan square theta, then 1 plus x square by a square, which is equal to under the root x square plus a square by a. Then we have our integral part, a secant square theta by root of a square plus a square tan square theta d theta. Then a can be taken out common, we'll get 1 plus tan square theta. Then secant square theta by root of secant square theta, we'll get secant theta d theta, which is equal to log of secant theta plus tan theta plus c, which is x by a plus root of x square plus a square by a plus c. Then log of x plus root of x square plus a square by a plus c, which is log of x plus x square plus a square minus log a plus c, where minus log a is a constant. So constant plus a constant is again a constant. So we'll have log of modulus x plus root of x square minus a square plus c.